Welcome back to my YT channel, to my YT world. This is again, I am a singer, eternal voice. Okay, our topic this moment in time is still related to thermodynamics and a little bit of physical chemistry in combination with chemistry. Okay, and then this is all about enthalpy. Okay, so I'm very open now. Let's off the AC. Okay. So this enthalpy is just the same with heat energy as Q. Okay, so we have the basic formula for that is equals to Q is equals to mcp dt, right? And we know that very well that Q stands for heat, M stands for mass, Cp stands for specific heat capacity, and dt is the change in temperature or the temperature difference, final temperature minus initial temperature, and the change in the temperature. Okay, so we have also another formula of heat, which is equal to the entropy times the temperature. Okay, like that. But the temperature used here is Kelvin with a capital T. Okay, this is the kind of heat formula that we will be able to use in the second law of thermodynamics and also in the first law of thermodynamics. So let's review. Check comprehension. Okay, for the first law of thermodynamics, we have Q is equals to the change in internal energy plus the work. Okay, so work, so it should be work done on the system. Okay, and the heat should be the total heat content, something like that. Okay, or the heat energy transferred from one point to another point, something like that. Okay, from higher temperature to lower temperature. Okay, now if we solve for internal energy, we have heat minus W. And in the second law of thermodynamics, we have also the gas-free energy relationship with the enthalpy. The enthalpy here is more related on Q, but this enthalpy changes is more on being a state function. It doesn't depend on the path, okay, where the reaction took place. This is dependent, okay, to the number of steps taken. So this is really a state function, okay, something like that. So it depends on the state, final initial, but doesn't depend on the path where it goes, something like that. So it is. So enthalpy is a heat function, and it is really a state function. Okay, something like that. And if this is the case, then why we subtract enthalpy from heat also? Okay, since we know that heat is equals to temperature times the change in entropy, right? So it could be delta H minus Q. So it's the same heat we are referring to. Meaning to say this enthalpy is the total heat content that we need to subtract to the Q, which could either be heat absorbed, heat released, like that. Okay? So enthalpy is more on heat energy transferred. Okay? Like that. And that gives free energy. And now we have this problem is all about enthalpy of combustion. So do not be confused with enthalpy of formation of the reaction. It's okay, we don't put formation, we just say enthalpy of the reaction. Okay, because in the reaction we have formation of the products and reactants. That's why it's called enthalpy of formation of the reaction. But actually it's just the same. Okay? To more it complete lang talaga siya. Okay? Enthalpy change of the formation of the reaction. Enthalpy of combustion is actually, it should be stated as enthalpy change of combustion. No need to say to put change also because enthalpy is really a change, okay, from final state to initial state. But it would be better also technically to put change. Okay, but it's just okay also not to put change when you say and discuss this in front of your students, or in front of your viewers, like that. So it could be enthalpy of combustion or enthalpy change of combustion, or it could be stated also as heat of combustion, because enthalpy, as I said over and over again, this is just only heat. Okay, it depends on the process that we are referring to. Okay, now this is the problem. Okay, calculate the enthalpy of combustion for 1 mole of liquid ethanol using the enthalpy of formation values. Ethanol liquid is equals to negative 27 kilojoules per mole. Carbon dioxide gas is equals to negative 293.5 kilojoules per mole. Water as a liquid is equals to negative 286 kilojoules per mole. Okay, guys, note each enthalpy of formation. This is formation because these are either products or reactants. These are enthalpy values or enthalpy values of formation, something like that. So check the positive and negative. And we need to look back also the relationship between the gives free energy, okay, the entropy and the enthalpy. So that it's easy for us to determine whether it is a spontaneous process, okay, spontaneous chemical reaction, non-spontaneous chemical reaction, and spontaneous chemical reaction. And that way, we can relate to their relationship. Could it be directly proportional with each other? Could it be inversely proportional with each other? So in that way, we can determine that our chemical reaction doesn't need an internal energy or external energy to proceed the reaction by itself. So it is reversible chemical reaction. Okay, or the reverse holds true if it needs an internal energy to proceed the chemical reaction, so it is a reversible reaction. Okay, so meaning to say a reversible reaction are non-spontaneous process. Again, a reversible reaction that doesn't goes back to its reactants and it needs really an internal energy to complete the chemical reaction is what we call as a reversible reaction or non-spontaneous chemical reaction. Whereas the reverse will hold true that it doesn't need internal energy or external energy, it will just proceed to back to its own reactants and products and then reverse with each other, and then that chemical reaction is called spontaneous chemical reaction or reversible chemical reaction. So in getting the values of the gives free energy, the enthalpy and the entropy, then we can determine what kind of chemical reaction really is. Okay, after solving this one. Okay, since we give each enthalpy formation of ethanol liquid negative 207 kilojoules per mole, negative sign, so this is less than 0. Okay, so by theory and concept, the enthalpy is directly proportional to the gives free energy. Okay, so if it is directly proportional to each other, so the value of gives free energy or the change of free energy is also negative. And if negative, that is spontaneous. Okay, spontaneous chemical reaction. So it is expected that this will be a reversible chemical reaction that doesn't require more energy or external energy or any amount of energy to proceed the chemical reaction. It will just go to its original state. Okay, because the value is negative. Okay, now if that is the case that the value of enthalpy and delta G is less than 0 or negative, automatically the reverse holds true for the change in entropy. So the change in entropy will be greater than 0. So we have a value of positive for the entropy. So the more it is in random and disorder, something like that. Okay, because our entropy is high, positive values, because inversely proportional to both enthalpy and gives free energy. That's why we need to determine the signs, the positive or negative, and that's the relevance of that principle and concept really. Okay, now going to the carbon dioxide, we have also the value of negative 393.5 kilojoules per mole. Okay, negative again. So again, it's spontaneous process or spontaneous chemical reaction. Water liquid is equals to negative 206 kilojoules per mole. So all are stated in non-spontaneous formation of the products and reactants. So automatically these are governing to the concept of reversible chemical reaction. Delta G gives free energy is negative, enthalpy is negative, but the entropy is positive. Okay, so it doesn't require any energy to proceed the chemical reaction. Okay, now required delta H combustion or change in enthalpy of combustion. Okay, actually this is also change in enthalpy formation of the reaction is just equal to the change in enthalpy of the combustion. Why? Because this is really a one type of chemical reaction which is known as the combustion chemical reaction that's belong to the 5 types of chemical reaction that I discussed last month in chemistry. So that 5 types of chemical reaction is very important here in dealing with the computation of the enthalpy changes of the chemical reaction. Okay, not only that, but also with the quantities of chemistry energy, entropy, especially dealing with chemical reactions. Something like that. It's very important. And then you know already the requirement. You have to balance the chemical reaction, chemical equation first to determine the stoichiometric relationship, the number of moles, then bingo, you can solve what is being required with certain conditions that satisfy to the operating condition to proceed the chemical reaction completely, and then you can solve what is being required in a particular problem. But in here, we need to solve the value of change in enthalpy combustion or the change of formation of a reaction for 1 mole of ethanol. Okay, class. So I will give you a hint in solving like this problem in, shall I say this is very closely related to chemistry, really. Chemistry or physical chemistry, okay? And slightly thermal, right? Because there's heat. That's thermodynamics. Okay, so that's why it's called specifically as the study of thermochemistry. Okay, it's under thermochemistry. Okay, because the word heat plus the chemistry that involves heat quantities or heat energy transferred from one point to another point, from high temperature to lower temperature, something like that. Okay, or you could say also the transfer of heat energy from the hot environment to the cold environment, something like that. Okay, it depends on the the phrasing on the problem solving presented to the question. Okay, like that. So what is the change in enthalpy combustion? Then you have to think, oh, okay, it's being asked the enthalpy change of the reaction. Okay, something like that. So you need to produce the chemical reaction. Because here, class, we don't have the chemical reaction given. Okay? Some problems will be like, especially in board examination, okay, Bachelor of Science and Chemical Engineering board examination, sometimes, not all the times, right? You don't have to put the chemical reaction. You will be the one to produce the chemical reaction. Okay? And the problem stated in words and statements, and you will be the one to break down that. And you have to predict the products, you have to predict the reactants, something like that. Everything. But sometimes also there is a given chemical reaction and you have to balance. In this situation, I need to get and extract the chemical reaction for this. So it's said in the problem, calculate the enthalpy of combustion for 1 mole of liquid ethanol using the enthalpy formation value. So this is combustion. So it will break down to carbon dioxide and water. Okay, hydrocarbon, okay, like that. Example, this ethanol will break down into carbon dioxide and water. And you should also familiarize the formula of the alcohol functional group in organic chemistry. Okay, because it doesn't mention here, it's the word ethanol only is putting here. Put here, ethanol. So what's that ethanol all about? If you don't know the formula for that, then you'll be also confused. So you have also a solid background of the organic chemistry to this hydrocarbon, because this ethanol contains carbon and hydrogen. Is under the study of hydrocarbon or organic chemistry. Okay, something like that. So I will show you now the formula of ethanol. I think that's very basic for chemistry, right? So we need to introduce the hydroxyl group. Okay. So I will just assume that you know the formula of ethanol, right? Okay. Wait for a while. Okay, ethanol. From the word ethyl, E-T-H-Y-L. So you have to take note of the formulation for this. The formula, for example, for the single bond, CnH2n plus 2, something like that. Okay? From the double bond, CnH2n. From the triple bond, CnH2n minus 2. Something like that, where n is equal to the number of moles. Take note, it's not the atoms, it's equal to the number of moles, the small letter n. And then substitute that there, then you can produce the formula of ethanol. From the word ethyl, of course, there's two atoms of carbon. Okay? Like that. So this is C2H5OH. Something like that. So I will start with C2H5OH. Guys, this is 1 mole, ha? Okay. C2H5OH. This is the chemical reaction. C2H5OH. Okay. Now remember, class, that in combustion, you have to add oxygen for its rapid oxidation to produce carbon dioxide in the water. Oxidation, remember, it's the loss of electrons. Okay, if it is the loss of electrons, then there will be an increase of the oxidation state and oxidation number. Okay, like that. So remember that one also. So it will be oxidized. Okay, like that. And the substance will be oxidized after the process of oxidation. Remember that one, the relationship for that, what is being oxidized, what being reduced, what is the reducing agent, what is the oxidizing agent. In here, automatically our reducing agent is the ethanol. Okay, because it will be the one to be oxidized. That's the reverse, right? The one will be oxidized are responsible for that are the reducing agent. So this is the reducing agent. Okay? So ethanol was oxidized through rapid oxidation of oxygen, and ethanol is definitely a reducing agent. Okay, ethanol plus oxygen gas. In here, class, in enthalpy computation of the combustion or reaction, we are very, very particular to the state of matter, whether it is a gas, liquid, or solid, and we need to put an open and close parenthesis at the subscript of the following element and compound. Okay, here, this is liquid, if we have to put small letter L. Okay, ganun siya. Okay. Since the problem states that 1 mole of ethanol, then this is the correct. We don't have to put any number besides or the coefficient of ethanol or ethyl alcohol. So equals to, okay, in this type of chemical reaction, we don't put the arrow as reversible, so that's not our concern. Enough that we know that it's a reversible chemical reaction, like that, because the symbol of reversible chemical reaction is to upward arrow right, put arrow left, meaning you have to go back to its original state and then come back again to the product. Okay, like that's why it's called spontaneous. Okay, especially like me. Sotero discussed very well spontaneously, meaning to say I did not stop. Okay, I talked very spontaneous and very fluent and verbatim without stoppage. Something like that. Okay, that's spontaneous, the way I talk to everybody, something like that. Okay, so talk in English in a spontaneous manner, something like that. So this is also in relation to chemical reaction, something like that. So the reaction has no stoppage, like that. There's no pause, P-A-U-S-E, pause. Okay, there's no stoppage. Okay, the reaction is really complete all throughout the process. Okay, it's just like that. The term spontaneous is just like that. Okay, if you look in the Webster dictionary, okay, something like that. So you can produce as carbon dioxide. So what will happen to your carbon dioxide? Of course, this is a gas. Okay, you need to identify the state or phase of matter because it has its own specific values of enthalpy information that is declared in the table or in the index of, could either be some reference textbooks in chemistry, physics, or in thermodynamics, or physically. We as chemical engineering students or chemical engineers, we have our own Paris Chemical Engineers Handbook. Okay, then we can scan it there. But usually in the problem solving, it will be stated there in the question. Okay, so CO2 gas plus, okay, water is liquid. Okay, because sometimes this H2O can exist also as a vapor state during the process of vaporization and evaporation. But here, this is not vaporization and evaporation. So the water here is liquid. So it will just be condensed, but the carbon dioxide will vaporize into the atmosphere. That's why the carbon dioxide is still gaseous state. Ganon. Okay, this is the first step. We need to determine the chemical reaction. Number two, we need to balance the chemical equation or chemical reaction one by one. Elemental balancing, huh? What do you mean by elemental balancing? Meaning you don't have to put the subscript. Okay, in putting hydrogen only, like that, oxygen only, don't put O2 like that. So do not carry the subscript during the balancing of the chemical equation. Okay, so carbon, okay, from the left, yung ganun siya. Okay, and carbon from the right. Okay, so the procedure, you need to start with the element before and then gas later, something like that. Okay, carbon is 2, and we don't have carbon on the other side. Okay, if we don't have carbon on the other side, let X, okay, the number of moles of carbon in the other side. So that is X times CO2. Okay, X. Just like algebra. Okay, so we assume this is in equilibrium stage. So that's why we said X is just equal to 2. Because we are assuming that this is an equilibrium stage during the chemical reaction. That's the purpose of why we balance it. Because we assume that the chemical reaction is in equilibrium stage. Okay, that's the main purpose. Or else we don't have to put in that way. If it is 2 here and the left 2 also in the product. The purpose, because we need to balance because of equilibrium state. Okay, to make it in a steady flow. Reactions, backward reaction and the forward reaction must be equal throughout the process. Something like that. There's a purpose. It's not just like it's not only as plain mathematics. We need to understand really why we do that. Why we need to put 2 here? We need to put 2 because that's the purpose. Okay, and that undergo the law of conservation of matter. Okay, something like that in chemistry. Okay, so X is just equal to we put here 2. Okay, I'll just put that 2 besides the CO2, but later I will rearrange that one after. Okay, now we go to the hydrogen. So it depends on you. If you start with hydrogen and oxygen, it depends. We will never choose because it can only be adjusted later on. So hydrogen, oh my gosh. Okay, hydrogen, the other side is 6 atoms. Okay. Why I said atoms? Because we consider the subscript. Okay. In balancing, we are not balancing only the number of moles. It's the atoms. That's why we have law of conservation of the mass. Something like that. Okay. So we have H on the other side. So H on the other side will be 2 only. So it's not balanced. So in the product side, there's 2. It's in the product side that we have to add 4 supposedly because it's deficient of 4 atoms. Then we can say for this as we relate the value of X of hydrogen atoms, still X on the other side. So we need to say that, okay, 6 is equal to 2x. You don't need to put x anymore because there's already x beside the carbon dioxide gas. So 6 is equal to 2x in equilibrium. Solve for the value of x. So x is equal to 3. Okay, something like that. Okay. But this is hydrogen. This is on the side of the hydrogen and for the CO2, sorry. Okay, so you have to put x in water here. Okay, you have to be careful, ha? Just like this. I quickly review. So you must quickly review also. Every time you speak. Okay. Like that. So that's the power of writing. Okay, not only telling or discussing, but you have to write really to match what you are going to speak will match the way you write it in the paper or anything. Chupa chuchu. Okay, so x is equals to 3, and then you have to put the 3 beside the water now because you left x, the number of atoms of hydrogen, beside water molecule. So x is equals to 3 now. Okay, and we have to balance the oxygen. Okay, oxygen. Oxygen in the right side is 3, and on the other side, 3 total, but we have to break that one. Okay, so 1 plus 2 or equals to 3. To make this understandable, 1 from ethanol plus 2 from oxygen gas. So we have 3 atoms total of oxygen in the reactant side. And our product side, we have oxygen here also. Oxygen and CO2 we have, okay, we have 4, okay, and on the other side we have 3 equals to 7, okay. Class, where is the deficient? It is in the reactant side, so we need to put more atoms in the reactant side. Always take note to put a number of atoms on the deficient side, not on the full atom side. Okay, so let's this we let this as 3x is equals to 7, and put x beside the oxygen gas in the reactant as the number of atoms of oxygen to equal the total number of atoms in the product side. Okay, like this. Solve for the value of x. So x is equals to 7,3. Okay, like that. 7,3, then put the value of the 7,3 or fraction to the above. Okay. Okay, class. We will divide a little bit here. 7,3 fraction, right? On the oxygen gas. And I will rearrange that one after that one. I will rearrange that as, okay, ethanol. I will explain you something. There's a little difference in chemistry. So C2H5 OH plus, okay, 7,3. Improper fraction, 7,3, okay? The numerator is greater than the denominator. That is improper fraction. So, 7/3 oxygen gas, okay, is equal to 2 moles of carbon dioxide gas, okay, plus 3 moles of water liquid. Now, this is our final reaction. Final reaction. Okay guys, so Sotero, why you leave that there's a fraction? You discussed before in chemistry that we need to avoid the fraction. In this case, we don't need to avoid the fraction because in the question in the problem, it states calculate the enthalpy of combustion for 1 mole of liquid ethanol. Then if we try to multiply that by 3 to cancel that out to make a whole number in the coefficient of this reactant product, then it will deviate the problem which states 1 mole of liquid ethanol. So just leave that as it is because that satisfies on our problem. 1 mole of liquid ethanol. Okay, so in short, kasagdahan ra nimong fraction diha because the problem states 1 mole of liquid ethanol. Combustion process releases carbon dioxide and water upon rapid oxidation of ethanol. Okay, so if doesn't state like that, then you can also have that to balance perfectly. But in here, it's mentioned kasi 1 mole of liquid ethanol. Okay, so if that is the case, leave as it is the 7/3 fraction here in the chemical reaction. Actually, we can multiply this both sides by 3 to avoid fractional to avoid fractional number of moles, but we don't have to do that. We don't do that because the problem states one mole of liquid ethanol. Or else, if you multiply that with a certain number to cancel that out, the number of moles of 7/3, then our number of moles for liquid ethanol will be no longer 1 mole. So our answer will be incorrect already in solving the enthalpy change of combustion of this chemical reaction. Okay, something like that. Now we will have the formula now. Okay, one by one. Okay, we have the chemical reaction now here at the bottom part of the paper. Okay, like this. We will be using this one. So our formula for change in enthalpy combustion or change of enthalpy of the reaction formation will be equal to something like that. Okay, I need another sheet of paper to do this. Oh my gosh. Okay. Okay, class. Okay. Change in enthalpy of combustion or reaction is equal to the change of enthalpy of formation of the product or products, if there are more products, times the number of moles of that products. Okay, summation like this, capital like this in a symbol in algebra also, like this, summation. Just like in an Excel format, Excel in computer, we have a symbol like this, summation. It's just the same, okay? Summation of the enthalpy change of the formation of the reactant. So first, our reactant will be ethanol, liquid. Okay, so we have to put here ethanol. Ganun siya. So delta H, ethanol, OH. All you have to do, class, is to be patient, to put the subscript, the variable, the nomenclature. Okay, ganun siya. Or else you'll become wrong. Okay, something like that. Okay? Now, we have two reactants here, the ethanol and the oxygen. But before proceeding, we need to multiply the number of moles of ethanol. Number of moles of ethanol, again, in the problem is only 1 mole. Then have times 1. Okay? Like this, times 1. I don't have to carry the mole. Later na lang siya because it will be cancels out all throughout the process. Something like that. So actually, this is ethanol plus 7,3 oxygen gas. But in theory and concept, remember this one is very important for all chemical engineers out there or whatever, or any engineering courses that have chemistry, especially in the topic of enthalpy. Okay, individual elemental components. Okay, the enthalpy formation of reaction at 298 Kelvin. Remember this one, could it be solid, liquid, or gas, automatically equals to 0. Okay, 0 kilojoules per mole. Okay, again, all free element, okay, pure substances and organic substances that exists as a monoatomic element, okay, alone, not a compound, it could be a gas, a liquid, or a solid, automatically the change of enthalpy of the formation of a reaction at standard temperature, we refer to 25 degrees Celsius or 208 Kelvin, is equal to 0. Okay, so I will add oxygen as 0. So nothing. I will not put any more. I will go directly to the change of enthalpy of the formation of the reactant. Always product under reactant. Okay? Like this. So 0 okay, like that. And then for water, we have, okay, the delta change in enthalpy formation of water. We have here, have siya, right? So like this, water, okay, have siya. Then in the reaction, the number of moles of water is how much? Here, try to look at it. So 3 moles of water. So multiply by 3. Okay. Okay. Then plus carbon dioxide, because carbon dioxide is a compound. Carbon dioxide, 2 moles of carbon dioxide. So enthalpy change of formation of carbon dioxide in a gaseous state, okay, times 2 moles. I always multiply with 2 moles for the reason of the given of the enthalpy is expressed in kilojoules per mole. But take note, guys, if the problems presented in the examination is already a kilojoules or joules, you don't have to multiply with the number of moles. Take note. Your answer will become wrong automatically. Okay? Understand? So you should use automatically the enthalpy value in terms of kilojoules, joules, or calories, or British thermal unit. Okay, another unit of energy. Because these are all energy: the enthalpy, the chemical energy, the thermal energy, the heat, the work. These are all types of energies. Okay, like that. So be careful also. In this case, the given in the problem is in terms of moles in the denominator. That's why we need to multiply with the number of moles. But there are instances that the tabulated or tabulation of the enthalpy, it's written in kilojoules only, then very happy. There's no moles anymore in the denominator. Then your formula also here, you will no longer multiply with the number of moles. Okay, sometimes it's very easy, but sometimes we take for granted for that. And it leads us to error, really. So the more it is basic, easy, and then sometimes the more we are taking for granted because we are focusing on the difficult problem solving and complex problem solving that we are used to solve. We are very, very fun and loving of solving difficult and lengthy problem solving, and then we overlooked the essence of the very easy problems, okay, that we need to use to be perfect solidly in the examination because that's easy, right? But what happens, we can never answer due to the fact we keep on thinking to the most difficult problem solving that we are used to in our subjects in our college. Because there's a lot of problem solving most of the times. Okay, too much numbers, too much mathematics. If we're taking engineering courses, a lot of mathematics will be there. I'll tell you honestly, and the theory and concept is not very that high. Okay, then when you take the examination, you're wondering why there's a lot of theories and concepts. Okay, so if the student's really focusing on the problem solving only, there's a time that his score or her score will be reduced because she is focusing only on the problem solving. Okay, you get the point? Okay, and he missed a lot in the theories. Okay? For example, what is the another term of linoleic acid? O, kaubo na. Okay? Something like that, the physical and chemical principles questions. Oh, wala na siya. Okay? So, you should be a wide reader. Wide reader. Meaning you have to read every seconds, every minute, every second, every minutes. Okay? Different types of books in sciences. Okay? Like that. Again, and read also new trends in science. So there are also science trivia questions also that will come out, okay, in the examination, something like that, or new discovery. Okay, so in this case, class, we need to reverse because the product is the ethanol. Okay, like that. So if you know really the concept, then you have to play around in your own initiative and strategy, especially if you have a very high IQ. Okay, no need to, detailed discussion, something like that. Okay, so the way I discuss this is very spoon feed and detailed because this is no time limit. Okay, something like that. Okay, so summation of H2O liquid because product siya. Okay, times 3 plus summation of CO2 gas times 2. Be careful also in picking up the number of moles because you will be wrong if you're using the wrong number of moles in each element of the reactants and the products. Okay? Like that. So enthalpy of ethanol liquid is, and times 1 lang siya, so no need to times 1 because it's already 1. Okay, that's understood. And then substitute values, guys. Okay? Okay? Product minus reactant siya ha, always. Okay? Product minus reactant. So the enthalpy change of the product times the number of moles minus the change of enthalpy formation of the reactants times the number of moles. Okay, like that. But if the values given in the problem doesn't contain the number of moles in the denominator, then no need to multiply that with number of moles. Okay? Like that. So substitute values data. Be careful in this. This will be the very crucial part in the substitution. Especially if you are very fast in solving the problem, then you will mislead the negative sign. Okay, so for the water guys, liquid negative 286 kilojoules per mole. So negative 286. I will carry now the unit. Kilojoules mole multiplied by 3 moles in the chemical reaction. Okay, 3 moles. So cancel the moles. Okay, plus the summation of enthalpy of formation of carbon dioxide gas. Okay, that is here, negative 393.5. Substitute that here, negative 393.5 kilojoules per mole times here times 2 moles. So times 2 moles. So cancel the moles. Okay, like that. Then this is whole quantity, ha? Whole quantity, put open and close parentheses. This is 2 added together so that you will not be confused. So minus the enthalpy of formation of the ethanol in 1 mole liquid. So mole will be cancelled also because 1 mole multiply that 1 mole of liquid ethanol, right? So the enthalpy of ethanol will be negative 287 kilojoules per mole times mole, then cancel na ang mole. Okay, so do the basic math for this. Basic math only because it's addition. Okay? When we mean of basic mathematics, we are only referring to plus, addition, subtraction, multiplication, and division. Basic mathematical operation. Okay? Like that. And in the real world, we can only live by that only for basic mathematics operation. Okay, the others are only additional. Okay, like that. Especially in the computation of the financial aspects, money matters. It's always positive, negative, minus, like the division of the. There's no other thing. You don't have to integrate. Okay, you don't have to differentiate just to have your annual interest. Okay. Something like that. So 393.5 plus 286 negative, okay, plus 287.5. So our enthalpy will be, so this is 287. Our enthalpy will be, again, review because the sign is very important. So 286, okay, negative plus 393.5 is equal to this is 4221 negative. So 4221 negative, okay, negative 4221, okay, plus, okay, ethanol is just only, like that. Be careful, ha? Okay. We just put one by one so that we will not be in error. Because, even me, I'm very, very eager to make it fast also. Okay? Yes. And that leads to error. Okay? That's my weakness. Okay? When I was in college, I am very quick. It doesn't mean I am good in mathematics. I'm very quick solving. And then, due to my quickness in solving, it leads me to error. That's my point. Okay? So possibly pala, you should be patient in doing that. Not too fast and not too slow. It's somewhere only in the average level. So it's gonna be like that to add the correctness of your answer supposedly. But never mind, it was done already. Okay. Like that. What I'm telling you that if that is really my attitude before, then you know the story. Okay? maybe I could have more score that I obtain in my chemical engineering result in the board examination. Okay, like that. 286 plus times 3 is equals to 858 negative. Okay, the negative din siya. So 393.5. It's just like you are very, very hungry to eat. It's just like that feeling, right? You have to make it fast, to eat very fast. Just like that feeling of solving problems. There are times like that also. Okay? And then your, here, your throat, you'll be like that. That's also the effect. And you will now to feel like that abnormalities in your abdominal pain. And then in solving problems also, you will get an error. It's just the same in analogy, okay? So we don't make too fast in everything that we do. Just, not slow and not too fast. It's in the average level so that we can increase the preciseness or the correctness of the answers. Okay? Something like that. Right? It does make sense. Okay. Oh my gosh. Don't rush in computation or calculation, okay? Like this. So minus in algebra, right? This is positive, right? If you can remember. A quantity minus a negative quantity, so it will become plus, right? You will put plus on the sign. That's a rule in algebra, right? So plus 287. Okay. Okay, pila na ni siya. Okay. 858 plus 787 is equals to, oh my gosh, 1645, negative 1645 plus 287. Okay, the answer is 1358. Again, review, 858 plus 787 is equals to, okay. Would you notice also in your first press of the calculator, you obtain the answer, and the second also press, there's another answer. That means there's something wrong when you press at first. Something you have to review like that. Okay. 858. Especially when you put too much pressure in pressing the numbers, then also you get an error. There are a lot of factors pala talaga siya in getting errors in examination. Not only that, how fast you are, very eager, like that. It's also the pressing of the calculator, like that. Okay, and the dirtiness. Okay, in your solution like this, you have too much erasures and it will confuse you. That's also add errors. Even though and there's a factors also you to become an error. Okay? Even though you study, but the way you handle in solving the problems ba. Okay? So there's a lot of factors. So we cannot say really that if you don't pass, bugo na siya. No, it's not. There's a lot of factors for that. Okay? In the actual scenario or situation. Okay? Okay. Like that. Okay? So it's really 1,358 negative, our enthalpy of combustion. Wow. Oh, really? Negative, so spontaneous. I love spontaneous. Wow. Talaga? Okay. Oh. Our enthalpy change of combustion of the reaction is 1,358 kilojoules negative. Oh my gosh, spontaneous. Meaning to say, no need of internal energy to proceed the chemical reaction. It will just proceed by its own. For example, if the ethanol will produce carbon dioxide, and then it will just reverse directly to CO2 plus water to produce ethanol in reverse. No need to add anything. You don't have to heat that one. Okay, you don't have to add any physical and ordinary chemical means or whatever. Any activities you will do, you will never apply pressure, you will never change the volume, you will never change the temperature, any factors affecting the chemical reaction. It will just proceed by its own. That's spontaneous. Okay, like that. So it's negative. the delta G is negative and the delta H is also negative because due to the fact that the enthalpy is directly proportional to the Gibbs free energy. Gibbs free energy will determine the spontaneity of the process, how spontaneous and how non-spontaneous the chemical reaction really is, or how fast or how slow the chemical reaction really is, or how exothermic the process really is, or endothermic the process really is. Okay, there's a lot of terms, right? You have to apply how spontaneous, how non-spontaneous it is, how exothermic, how endothermic it is, how slow or how fast it is, like that. Okay, how reversible and irreversible it is. 4 terms. Okay, sometimes it will be asked in another way around. Something like, for example, this is the problem in the examination, this one. And then question letter B, is the chemical reaction is a spontaneous reaction? Like that. And then you obtain already the negative here. And you have the theory and concept that if the negative value of enthalpy, that's spontaneous, then you can answer, right? And then another question, is the chemical reaction is reversible or irreversible? Okay, since you know that it's spontaneous, that it's reversible, something like that. Okay, that's negative. No need of internal energy or any energy outside factors. It will just proceed by its own. Oh, reversible chemical reaction. Is the reaction is exothermic or endothermic? Now, we need to think for this. Okay, now we will review. Even me, I will be confused for this term. Now, we have the process. Process composed of a system and a surrounding. Surrounding is also termed as environment, right? We have me, I'm sitting here, I have the surrounding, this is my room, okay, something like that. And my system here, I am sitting and holding my talking, it seems like that. And then, I have the enthalpy by myself of negative. Okay, since that is a negative enthalpy, that is negative heat, meaning to say, I remove the heat from my system. So if I remove my heat, I release my heat from my system, and then I release that to the surrounding. Okay, if you release that to the surrounding, what will happen? That is exothermic reaction. Okay? Exothermic reaction. So, if the question was it is exothermic reaction, the combustion of ethanol, your answer will be exothermic because you have a negative enthalpy, something like that. Theory, okay, something like that. So, that's gonna be the answer. Okay, because if you will absorb, I'm not consuming heat, okay, because the surrounding is not giving heat to me. I am the system. Okay? If the reverse holds true, then that is endothermic. Okay? I will absorb and consume the heat given by the surrounding to me because I am a system. Something like that. Okay? So the reverse of heat release is heat absorbed. So the other one is positive. Now, if the surrounding will release heat to me as a system, that is, okay, that is also already an exothermic to me. Right? You understand now the point? It is an exothermic reaction to me in the system. Okay? And it's already an endothermic to, like that, to the other surrounding. Something like that, okay? So, if you release, the surrounding will become exothermic. So, meaning to say, never mind that too much. As long as it's negative, then exothermic, something like that, okay? Okay, for the reason also, if the delta G is less than magud siya, so 0, exothermic magud siya na yun. Okay? And the reverse will hold through. Okay, like that. Then if you release it also to the surrounding, then the surrounding will become hot. So that is exothermic. If the surrounding will become cold, then that is endothermic. Okay? Like that. Okay, meaning I am absorbing, me as a system, I am absorbing the heat from the surrounding. Right? I cannot explain very well, it's on my brain cells. Okay, just ask me personally in the messenger, okay, so that we can agree with each other, okay? But in physical chemistry and thermodynamics, we are referring to the system magud siya. And in chemistry, we are referring to the surrounding. That's why the positive and negative sign will not agree. If you really understand, even though it will be rumbled, you can still understand the sign. That's my point. Okay? Like, for example, in chemistry, delta U or change in energy is equal to Q plus W man siya. But in physical chemistry, change in internal energy is equal to heat minus W. Why? Because in physical chemistry, if you done work by the system, is negative because you are losing energy by the system. But in chemistry, it's not. It's considering the work delivered to the surrounding. Something like if the work is delivered away from the surrounding, that's negative. That's why it becomes delta U Q minus W because the chemistry is always referring to the surrounding. Okay? Surrounding. For example, if this is a laboratory, I have the reaction of ethanol and water here in my table. I do the experimentation. For example, I use the gravimetric analysis in quantitative chemistry, something like that. So my system is I do the, the adding of the oxygen gas, something like that. Example only, and the ethanol. So that is my system. And my surrounding is the laboratory. Okay, so the effect on the laboratory, on the surrounding, is what the chemistry is referring to. Okay, reverse as a physical chemistry and thermodynamics, they are referring on the mixing of the ethanol and water. What's the effect in there? Okay, that's why the sign will matter. Okay, the positive and the minus will matter. Okay, so actually I did not understand this very well when I was in college. Okay, but I review a lot and now I really understand. I'm now really a registered chemical engineer when I understand fully this kind of principles and concepts, to be honest with you guys. Okay? So before, I understand really, but it's sort of 70 to 80% lang siya. But now, 80% up, I really understand the concept for this, okay, process, system, and surrounding. Okay? Because I will never stop learning, even though, okay. You know what I mean. Okay, something like that. So thank you so much if you listened very well to this informative or academic information regarding physical chemistry and thermodynamics, regarding the focus of enthalpy change of combustion or heat of combustion, enthalpy formation of the products and reactants, something like that. Okay, so thank you so much. If you like this video, then you can click the notification bell for some newest updates that I am a singer, eternal voice. If you want some academic information, especially or particularly science, then you can stay with my channel. And also I'll be doing some singing moments also, but not always singing moments because I have no revenues for singing moments because always have copyright claims. Copyright claims meaning if you upload that in your YT channel, you can never gain revenue for that because the publisher, the recording company will not allow you to circulate your performance to the entire world. So they will be the one to get your revenue. So if that is the case, they will keep on getting my revenue when I sing. So what's the use? Okay, so it's not also useful for me. That's why I I uploaded it in my other channel. I have another channel. This is the exclusive singing. Sotero and exclusive singing. It's in there that I uploaded all my singing moments there. I also upload singing moments in this channel, but more on science academic information, especially also occupational safety and health. Okay? In combination of pure sciences, something like that. And some personal vlogs. Okay? Oh my gosh. It's low bat already. Oh my gosh. I have to charge this. I have to charge this microphone. Bye-bye everybody. God bless. Bye-bye. Stay tuned. See you later.